All right, today we're going to be learning about arithmetic sequences and series. An arithmetic sequence is a pattern where the same number is added to each term. So every time from one number to the next, we're going to be adding the same number. So here's some symbols that we're going to be using in our formulas for this. We have this big E looking thing. This is called sigma, which means sum, as in add them all up. D is going to stand for our common difference. This is your number that you're adding by each time in the sequence. A sub n is your nth term. A sub 1 is your starting term. S sub n is the sum of n terms, and n is the number of terms. So let's look at these sequences and figure out if they're arithmetic. It goes 4, 7, 10, 13, 16. This one is arithmetic because our common difference is 3. It's going up by 3 each time. Number 2 goes 3, 6, 12, 24, 48. Well, between 3 and 6 is only 3. Between 6 and 12 is 6. So this is not arithmetic because it's multiplying by 2. If you're multiplying, it's no, because this says it has to be adding. Number 3 might seem like it's not arithmetic, but it is. We're adding, but this time we're adding by a negative number. So our common difference is negative 5. And then number 4, it is adding something each time, but it's not arithmetic because it adds a different amount each term. It's still a pattern because it adds 1, then it adds 2, then it adds 3, then it adds 4, but it's not an arithmetic pattern because it's adding a different number each time. So this is one of our first formulas. This is our formula to find the nth term. So we can use this formula to find any term in a pattern. So find the nth term and give the find the nth term given a common difference. So if it's asking you to find the nth term, the one thing that trips up students a lot is this means write an equation. So we're going to keep a sub n as the first thing. A sub 1 we were told is 2, so we're going to plug the 2 in. Plus d, since it's plus a negative d, we're going to use minus d times n minus 1. And that's it. That's all you have to do. You cannot subtract these 2's because this negative 2 is connected to the n minus 1. You can't simplify this. Don't simplify this. Do not simplify this. Leave it as it is. That's it. You're done. It is as easy as it seems. Now, write a rule for the nth term. Again, directions that sometimes mess students up. This also means write an equation. Now, in example number 5, they told us what D and A sub 1 were. We need to figure that out this time. A sub 1 is our starting term. We started with 19, so that's equal to 19. And then our common difference is going to be what we're going up by each time. That's right, it's increasing by 4. So we have A sub n equals 19 plus 4 times n minus 1. That's the first half of this equation. Or sorry, first half of this problem. Then find A sub 15. What that's saying is we want the 15th term. Now, if you wanted, you got the first 5 terms, you could just keep going with the pattern and write it all out till you get to the 15th. That's fine, show me all that work, you're good to go. The shorter way is if we want the 15th term, that's what equals n. So we're going to plug it in for the n here. 19 plus 4 times 15 minus 1. Type it all in one line in your calculator, and you get that the 15th term is equal to 75. All right, next type of problem. All right, so again, it's asking us to write the rule. So again, we're writing the equation. If we're writing the equation, the two things we need to know are a sub 1 and the common difference, neither of which we have this time. So in order to find the common difference, we're going to take our two terms and subtract them. So 48 minus 18. Basically, we're finding out how much space is between the terms. Then we're going to subtract the term number, so 10 minus 4. So we have this much space to cover and this many terms to cover it in. So we get 30 spaces over 6 terms, so we must be going up by 5. Then there's two different ways we can find a sub 1. Since we already know a sub 4, I would work backwards. If we're going up by 5, the previous term was 13. The term before that must have been 8. The term before that would have been 3. So a sub 1 must be 3. So we're going to write the equation. A sub n equals 3 plus 5 times n minus 1. Now, a way to check that this equation works. Let's take this 10th term and 48. When n is 10, we should get 48. So let's check it out on our calculator. 3 plus 5 times 10 minus 1. If we did it correctly, we should get 48. There you go. We're geniuses. All right, so we've looked at how to find a sub 1, we've looked at how to find d, we've looked at how to write an equation. Let's see if we can figure out a term number. So determine which term is 57 in the sequence. So it's saying 57 comes up somewhere in this pattern. We're starting at negative 59, and our numbers are doing what? They're going up by 4. So a sub 1 is negative 59, d is 4. So we know that 57 is our final answer. That's our term. We know we started at negative 59. We're going up by 4. We want to know how many terms it takes us to get to 57. So there's a couple different ways to do this. Most people like to distribute first. So we have 57 equals negative 59 plus 4 minus 4. Combine like terms, we get 57 equals negative 63 plus 4n. Add 63 to both sides. 4n equals 120. Divide both sides by 4. N equals 30. So 57 is the 30th term in the pattern. If you didn't want to do all that work, you could keep writing the pattern all the way till you got to 57 and count how many terms there were and determine that it was the 30th. But I mean, this was 30th. That's not that bad to write out another 26 terms, but that work's not going to be fun if it's like the 90th term. So that's different things to do with sequences. Now we're going to talk about finding the sums of these sequences. So here's our equation for a sum. We take the number of terms and we multiply that with the average of the first term and the last term. So in number 9, our first term is 2. We don't know what our last term is. We just know we want the 19th term. So in order to do this, we're going to have to write an equation again. So a sub n equals our first term is 2 plus, we're increasing by 1 each time, 1 times n minus 1 would be our formula for this sequence. To find the 19th term, we're going to plug in 19 for our n. So 2 plus 1 times 19 minus 1. That tells us that our 19th term is 20. So now we have all our information to plug in here. S sub n equals, we have 19 terms, times our first term was 20, or sorry, our first term was 2. The last term we're using is 20, and we're going to divide that by 2. Type all that in your calculator. Remember, you can use the flat fraction that we have. So 19 parentheses alpha y equals, enter, 2 plus 20 over 2, close the parentheses. The sum is 209. And what this formula is doing for you is taking the first 19 terms in the pattern and adding them all up. So if you really wanted, you could write out the first 19 terms and add them all up, but the formula is a lot shorter. So number 10 is a different way of writing the sum, but we're still going to use this formula. So our first term we're going to get by plugging in the number on the bottom into here. So a sub 1 equals 4 times 1 plus 1, which is 5. To find our nth term, we're going to do the top number and plug that in for n. So we want the 25th term, 4 times 25 plus 1, which equals 101. Then let's plug everything into our formula. S sub n, how many terms are there from 1 to 25? That would be 25 terms. Our first one's 5. Our last one's 101. Divide that by 2. Type it all in your calculator, and you get a sum of 1,325. All right, number 11. This time it wants to start at the third term, so we plug 3 in. A sub 3 equals 5 times 3 minus 2, which is 13. And we're going to the 14th term on the top. So we plug 14 in. 5 times 14 minus 2 is 68. Now, when the bottom number is not 1, students often get messed up with how many terms there are, what our number for n is going to be. So let's look at this. We're doing the third term, the fourth term, the fifth, the sixth, the seventh, the eighth, the ninth, the 10th, the 11th, the 12th, the 13th, and the 14th. Now a lot of people want to say, oh, from 3 to 14, that's 11 spaces. There's 11 terms. But look, there's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms. So be very careful about what value you're using for the n when you have n not equal to 1 on the bottom. Now we can plug into our formula. S sub n equals 12 times 13 plus 68 over 2. S sub n equals, put that in your calculator, you should get 486. That's all for today. See you in class.